Okay, welcome everybody to day 2 of the Pediatric and Developmental Cell Atlas. We've got a really exciting day today. We had a really exciting day yesterday. Um, at the close of comments yesterday, I made some fairly outlandish claims about our state of play and how we're going to develop discovery resources. And so I made a big Excel that's now available in the resources link that you can download. And what I wanted to get across is what is our state of knowledge of what is development, what are the genetic mechanisms, cellular mechanisms, what are the processes, what do we know so far, how do we make everything that we're discovering now in a cell-associated way, a tissue-associated way, available to the community. And so just a sense of how non-coordinated some of our knowledge sources are. This is gene ontology versus gene knockout, just showing you there's tons of abnormal embryonic development genes that are not in any go category right now. And then same with growth as well. And so I'm going to offer a prize. If anybody can name one out of the 47 genes that intersects with human phenotype, mouse phenotype, and gene ontology knowledge, any of these 47 genes, enter it into the chat and you will win a Legoland gift card prize. And just showing how in an organ-centered way, how different genes are associated with abnormal development of an organ system. You can see there's many genes that are outside of that are specific to a given system. Neurodevelopment, cardiac development, immune development, skeletal development, goes on. And so incredibly central roles for the genes that intersect, incredibly powerful roles for the genes outside of it, and they're in all sorts of molecular function categories: transcriptional control, signal transduction, cell-cell interaction. And here's some fun views of what you can do with that, and taking this kind of prior knowledge and then moving it into a given system where we're developing an atlas and then mining the atlas to really focus in on some key problems that are translatable is I think part of our business. So what's the best way to build atlases that are informative? What are the best ways to analyze them in a systems based way? How do we help people develop hypotheses out of it? This is bone development. Here's growth hormone receptor. Every single one of these receptors has a bone development phenotype that's abnormal. There's many bone disorders that are not responsive to growth hormone. So this should be a light bulb for people to reason. And so about possible other modifiers to help people with bone disorders. This is off of Emily Farrow's poster, so I encourage you to look at it. Oops, okay, don't have the next slide. But so it's in this vein that we've invited Kat Hedjanatakis to take us into this exploratorium of, oh yeah, here we go. So what we're trying to do is build a Legoland of opportunities for discovery, and some assembly is required, and we couldn't think of a better person to help us on that than Kat Hedjanatakis. So there's validation, there's thinking about implications, translation, all of that. She gets that. So thank you so much for agreeing to give the talk.